So in this video, we are going to solve questions from exercise 13.4, which belongs to chapter number 13, surface areas and volumes. Okay. So let's see what is question number 3. I'm going to zoom in. Okay. So find the total surface area of a hemisphere of radius 10 centimeter. Use pi equal to 3.14. So quite a simple and straightforward problem. We have to calculate the total surface area. I'm just going to highlight it. We have to calculate the total surface area of the hemisphere, which is of radius 10 centimeter. So we know what the formula is. So I'm just going to write here total, okay, total surface area of hemisphere. I'm just going to write h dot is equal to is 3 pi r square. Okay, so that is equal to 3 into pi is 3.14 and r square is 10 square. Okay, given radius is 10 centimeter. Now, so that's going to be equal to 3 into 3.14 into 100. Okay, 10 square is 100. So let's come down. So that is equal to 3 into 314. Okay, and that is equal to 4 3s are 12, 1 1 carry, 3 1s are 3, 4, 3 3s are 9. 942 centimeter square. Unit is very important. Okay, without unit, this is just a mere number 942. It has absolutely no sense. The units are very important. So 942 centimeter square becomes the total surface area of the hemisphere with radius 10 centimeter. So quite a simple and straightforward problem. There was nothing complicated in it, just straightforward use of the standard formula. Now let's see problem number 4. I'm just going to pull this down. Yes, so this is our problem number 4. So let's focus on it and try to read it. Okay, let's try to, yeah. So the problem reads, the radius of a spherical balloon, okay, increases from 7 centimeter to 14 centimeter as air is being pumped into it. Okay, find the ratio of surface areas of the balloon in the two cases. So again, very simple and straightforward problem. First, we have to identify the three-dimensional solid figure that they are talking about. So here it's very clear they are talking about a spherical balloon. So they're talking about sphere. So first they had a sphere with radius as 7 centimeter. So I'm just going to write here. I'm going to write a radius 1 is equal to 7 centimeter. And then from radius 1 they went to radius 2 R2, which became equal to 14 centimeter. Okay, so as the air was being blown into the sphere, its size changed from 7 centimeter to 14 centimeter. Okay, and now we have to find the ratio of the surface areas of the balloon in the two cases. Okay, so first of all, what will be the, yes, so what will be the surface area here? Surface area of the sphere in this case, okay, is going to be equal to 4 pi r1 square. Okay, 4 pi r square is the formula to calculate the surface area of sphere, and this is 4 pi r1 square. Okay, now let's use a different color, and in this case, okay, let's use black, and in this case, now the surface area of this, so let's call this sphere 1, just for sphere 1, and surface area of, let's call this sphere 2. Sphere 2 will be equal to what? It will be 4 pi r2 square. Okay, so 4 pi r1 square, 4 pi r2 square is the surface area of both these spheres, and now we are supposed to take the ratio. So therefore ratio of surface areas, so ratio of surface areas will be equal to what? It will be 4 pi r1 square divided by 4 pi r2 square. Okay, now you can clearly see that 4 pi is common both in numerator and denominator, so they will cancel each other out. So I'm just going to cancel 4 pi, and what remains here, let's continue. What remains here is r1 square the whole divided by r2 square. Okay, so this can be written as r1 divided by r2 the whole square. Okay, I'm just transferring the square power or the square exponent to the entire fraction. Okay, so this and this is same. Now we know what is r1, we know what is r2. So r1 is 7 centimeter, r2 is 14 centimeter. So we're just going to substitute these values here. So that is equal to 7 divided by 14 and the whole square. Okay, so 7 divided by 14 is half, so 1 by 2 and the whole square, and 1 by 2 the whole square is going to be 1 by 4. So 1 by 4 is our answer, which is the ratio of the, let's zoom out, yes, which is this ratio of the surface area of both these spheres, sphere 1 and sphere 2. So 1 by 4 is the answer. Let's come here. Yes, so as you increase the radius of the sphere from 7 centimeter to 14 centimeter, the surface area will become 4 times. Okay, so find the ratio of the surface of both the cases. So, okay, I'm just going to write here the required answer ratio is 1 by 4. That's it. These are the two problems.